Okay, so law of sines is super, super easy to remember. Uh, Probably don't even need to write it down. The sine of angle A, ratio of the sine of the angle A to the side length across from angle A is the same as the ratio of the sine of angle B to the side length across from angle C, across from B, which is also the same as the ratio of the sine of angle C to the side length across from angle C. So basically it's saying that for all three angles, the ratio of the sine of the angle to the length of the side across from it is always the same for all three angles in a triangle. So simple to apply it. So in this case, and notice for the law of sines, um, you have to have one ratio complete in order to use it. Notice here we have the 65-degree angle and the side across from the 65-degree angle. If we had this scenario, we would not be able to use the law of sines because we don't know either side length across from. No, I take that back. We could use the law of sines in this case because since we know these two angles, we could determine this angle from the triangle sum, the 180. So we still could use. So if you know 2 out of 3 of the angles of a triangle and one side, you can absolutely use law of sines no matter where the side is. If you know two of the angles of the triangle, then law of sines will figure out everything. Will be the first step to figuring out anything else. So let's put it back up here. Um, in this case, we know that the sine of 65 over 5 is the same as, oh, and let's say we wanted to figure out this side length right here, x. That would be the same as the sine of 35 over x. And you cross multiply and solve algebraically for x. It's a piece of cake. And something else I might add, this third angle here, see 9, that's 100 right there. So this angle right here would be 80 degrees. So which of the three side lengths, let's say this is y. X is going to be smaller than 5 because 35 degrees across from x is smaller than 65 degrees across from the 5. Y is going to end up being the longest side because it's across from the largest angle. That's a principle to remember when working with law of sines to make sure your answer is reasonable. So now here we go. We've got uh, uh, same thing. We got well here we have um, again 65 or 5. We have that complete ratio. So the sine of 65 over 5 is equal to, let's call this x degrees. Well, that's the sine of x over 4. So you cross multiply 4 times the sine of 65 equals 5 times the sine of x. So you end up dividing by 5, and that's the sine of the angle. So you put that in the calculator, 4 times sine of 65 over 5, and then you do inverse sine of that of this to get figure out what the actual angle is. And notice again, since the 4 is smaller than the 5, this angle here is going to be smaller than 65. Okay, so the triangle that I had before, I'm going to move, let's say the 65-degree angle is up here. I can no longer use the law of sines because I do not have one of the ratios complete. I know this angle, but I don't know the side across from it. I know this side, but I don't know the angle across from it. And I know this side, but I don't know the angle across from it. You have to be able to complete one of the ratios in order to use the law of sines. So this is an example of where the law of cosines comes in. The law of cosines says it's actually a play on the Pythagorean theorem. It's um, c squared equals a squared plus b squared. That's Pythagorean theorem. But, and the law of cosines works for right triangles too. It's just that you don't need it. Here's why. Minus 2ab times the cosine of angle C. It just so happens that the cosine, if the angle between the two sides that we know is 90, it just so happens that the cosine of 90 is 0. So this whole term disappears if the angle C is a right angle, turning the law of cosines into the Pythagorean theorem. Now, so to apply it, we, let's say that this is the side we're looking for, and it's a side angle side scenario when you use the law of cosines. Look at that side angle side scenario. So we would say x squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of the angle across from the side we're looking for. You crunch all that out, you take the square root, and you've got the value of x. The other scenario where you can't use law of sines is when you have all three sides, but you don't know any of the angles. We could figure out any of the three angles using the law of cosine. Let's figure out this angle here. Since this is the angle we're looking for, this is the side that we isolate. The 5 squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of that x angle. So we subtract everything across. 5 squared minus 4 squared minus 6 squared. And then we divide both sides by the negative 2 minus 2 times 4 times 6. I could do the arithmetic there. And all of that equals the cosine of x. So you crunch all that out. I'll go ahead and do that. Now I'm going to be 25 minus 16 is 9. 9 minus 36. That would be negative 27. And divide that by negative 48. Negative 48. Okay, so 0.5625, we take the inverse cosine of that answer and find that this angle is about 56 degrees. Okay, so now just quick summary as to when to use law of sines and versus law of cosines. If you know 2 out of 3 of the angles, like 40 degrees here and 55 degrees here, then that would be a law of sines. You'd have to also know one other piece of information, like the side. Even though you don't have the complete ratio, remember you can complete one of the law of sines ratios by figuring out what this angle is. Okay. If you have 2 angles, you use a law of sines. 2 angles and one side, no matter where that side is. Now, if you have 2 sides and 1 angle, like 6, 5, and 1 angle, then it's going to depend on where that angle is. See, in this case, the angle, the 40-degree angle, we don't know what this side over here is, so we can't use law of sines. We'd have to know one complete pair of angle opposite side, but we don't have it, so we'd have to use law of cosines here. If the angle's over here, we've got a complete ratio in the law of sines. So we can use the law of sines. Or if the angle is here, we have a complete ratio out of the law in the law of sines. So we could use the law of sines. So as long as you have a complete ratio, or you can figure out a complete ratio, one of those, you know what I'm talking about, the ratios, these ratios. As long as one of them is complete, you can use law of sines. If you can't complete one of those ratios, then you have to use law of cosines. The two scenarios that call for that are where you have one angle and the two sides that surround that angle, and the other scenario that is when you've got all three sides of the triangle and you can figure out one of the angles using the law of cosines.